Welcome to the Sun Today, a supplement. I'm trying to answer the question, are we at solar maximum yet? Here we see two pictures of the sun taken by the same instrument in the same wavelength, that's 171 angstroms or about 600,000 degrees Kelvin. So this is in the transition region of the sun, not the corona. On the left we have an image taken in 2019 at the depth of solar minimum. You can see the sun is basically featureless, this sort of haze of X-ray emission with very, very few bright areas which would correspond to sunspots. On the right we have an image taken in 2024 near or at solar maximum, and you can see the structure of but the $10,000 question is, when will solar maximum be for solar cycle 25? Well, let's take a look at some of the data to see if we can learn something from that. We have the sunspot numbers for solar cycle 24 and solar cycle 25. The yellow data here is the daily data, and you can see that's highly variable and you can't really determine very much from that at all. The blue is the monthly averaged data, and that's still, there are lots of bumps and dips in there, but you can see some general trends. But the quantity that's used to determine when solar maximum and when solar minimum are is this red curve, the monthly smooth. They take a running average of 13 months. The most recent point on the right of the curve here is for July of 2024. And that curve has been rising steadily for the last few years and is still doing so. We haven't seen a turnover yet. The models that the Solar Inferences Data Center use show the turnover due anytime now. The maximum from solar cycle 24 was April of 2014. And so we can say that the maximum of solar cycle 25 will be any time after July of 2024. So when will solar maximum be? There's several different methods of determining it, and unfortunately they give lots of different answers. But let's take a look at them individually. First, based on an 11.1 year solar cycle, take the peak of the last cycle of April 2014, add 132 months to it, and that becomes May of 2025. The average shape of a cycle can help us. Here are all the different cycles, and that's the normalized shape you have there. And that would give us 48 months after solar minimum, which would be January of 2024. The average rise time is another parameter you can use. That's 52 months, so that would give us April of 2024. We could wimp out on this and take the fastest rise, which would give us March of 2023 as the peak, compared to the slowest rise, which would give us October of 2026. And we can, of course, eliminate some of these dates because they've already passed and we're not at solar maximum yet. There's another promising sign that we're near or at solar maximum, and that's the formation of this coronal hole in the northern polar regions. The poles reverse polarity at approximately the time of solar maximum. It's within a year of solar maximum on average, so that's not necessarily a very fine measure of when the solar maximum will be, but it's certainly an indication that we're at or near it. Is there another way? There is. And I've just developed this method in the last few days. As some of you know, I've been doing research on solar cycle for many years, and this is an idea that hadn't occurred to me before. But anyway, one can take the area of sunspots and compare the northern hemisphere and the southern hemisphere and see when each of them peak individually. This is what I got. So if you take the average sunspot area for each month and plot it individually for the two hemispheres, you get this. The blue here is the northern hemisphere, the orange here is the southern hemisphere. And you can see for the first few years of this cycle, the two have pretty much been in lockstep with one another, with just random variations above and below. But in the last year or so, the southern hemisphere has been quite dominant. And so this could quite easily indicate when the peak will be. But it's still very sketchy because of so much great variability. So let's take a look at a different way of looking at this using the 13-month smooth method. And this is what I got. Again, blue is the northern hemisphere, orange is the southern hemisphere. And we have a peak in the orange curve in December of 2024. So I'm betting at the moment that's the most likely date for solar maximum. But you notice that the northern hemisphere really hasn't had very much of a peak at all. It's just been bumbling along for the last 2 or 3 years. Except for right at the end here. The northern hemisphere has made a sudden jump, and could it too be producing a peak rather similar to this one from the southern hemisphere? And then the question will be, how big will it be? Is it going to be larger or smaller than the one from the southern hemisphere? And how soon will it occur? The other thing that this tells us is, of course, if these two peaks are out of phase by a long way, we'll have a low cycle. If they line up fairly well, we'll have a high cycle. So this phasing of these two, the northern and southern hemisphere, is vitally important in determining how big the solar cycle will be. And that's something I don't think people really take into account. So what can we conclude from all of this? Well, first of all, solar maximum will be in July of 2024 or later. There are signs that we are at or very near to solar maximum. My new sunspot area analysis shows that a strong peak in December of 2024 in the southern hemisphere, and that may be a candidate for determining when solar maximum will be. But the question is, what about the northern hemisphere? And that's to be decided as yet. Once again, thank you for listening. If you enjoy these videos, please pass them on to friends or neighbors or relations who you think might benefit from understanding more about how the sun works. And so until next time, stay safe and goodbye.